Hey everyone. So we're next gonna just do a little bit of review here, and then we're gonna have eventually a quiz on some of the derivative applications that we've been doing. So the do now here says the graph below shows the graph of f prime the derivative of f. Using the graph, find the critical values of f and identify each as a relative x maximum, relative min, or neither. Now remember, this is not the graph of f of x, so we're not looking for the turning points. This is the graph of f prime, so it's telling the slope. So here, what we're looking for is this is positive, this is negative. So where is the slope changing from positive to negative? Well, when you plug in a certain number, you get the slope since this is the derivative. So everything down here has a negative value, and everything up here, positive, negative, positive. So what are we talking about here? Where does the slope go from negative to positive? At 0, it goes from negative to positive. So what does that mean? Well, think about it. Remember, if we do our f prime test, our first derivative test, what it's saying here is the slope is negative until when? Until 0. And then it becomes positive until when? Until 2. And then it's negative until 4, and then positive after that. So what do we have? We have down, up, down, down, up, down, up. So we have a minimum at 0, we have a maximum at 2, and we have a minimum at 4. Okay? Let's do some practice here. Find the third derivative of this polynomial. Well, f prime of x is going to be 4x cubed minus 30x squared plus 1. F double prime will then be 12x squared minus 60x. And then f triple prime, 24x minus 60. Nice easy start. Let's go to a little more difficult here. So here it says find f double prime if f of x equals 4, parentheses 3x minus 4 to the fourth. So we have a little chain rule here, right? Derivative of the outside times derivative of the inside. So that means f prime of x is going to be 16, 3x minus 4 to the third, right? Decrease the power by 1, times the derivative of the inside, which is 3. And you could simplify this by doing 3 times 16, which is 48, parentheses 3x minus 4 to the third. So now at f double prime, we have to do chain rule again. 3 times 48, which is 144, parentheses 3x minus 4 to the second, decrease the power by 1, multiply, decrease the power by 1, and now derivative of the inside times 3, which you could simplify. 3 times 144, 140, 284, 20. I think it's 436 times 3x minus 4 squared. Okay. Here we go. The graph below is the graph of f prime of x. Find all critical values and relative extrema for f of x and determine the intervals where it's increasing. It doesn't say decreasing, so just increasing. And determine the intervals where f of x is decreasing. Oh, there you go. Okay, so again, this is the graph of the derivative. So when we're talking about the graph of the derivative, everything above 0 means when you plug in a number into the derivative, you get a positive number. And down here you get a negative number. When the derivative is positive, it means it's increasing over that interval. When it's negative, it means it's decreasing. So let's highlight all the regions where it's negative. And now we'll highlight all the regions where it's positive. So let's make our first derivative test. All right, from 0, I guess we have a closed interval here, so from 0 to 1, negative. From 1 to 4, positive. From 4 to 6, negative. And then from 6 to 9, positive. So that means it's decreasing, then increasing, then decreasing, then increasing. What does that tell us? Well, that tells us when the derivative is negative, the function is going to be, original function is going to be going down, but then it changes. Oh, that's a mistake. It's supposed to say 2, sorry. So up to 2, the derivative is negative, but then it starts becoming positive. That means there's going to be a minimum. At 4, a maximum. At 6, a minimum. I'll write that down here. Okay, so there's the relative extrema. We don't have an original function, so we can't find out what. We just know the critical values. The critical values are 2, 4, and 6. 2, 4, and 6, where the derivative goes from negative to positive or positive to negative. Okay, then it says determine the intervals where it's decreasing. Well, where is it decreasing? It's decreasing from 0 to 2 and 4 to 6. All right, that's decreasing. And then increasing from 2 to 4 and from 6 to 9. Cool. Number 4, f of x equals negative 2x squared plus 8x minus 9 on 0 to 4. Find all x coordinates for the relative extrema. So that means we have to find the critical values. So first let's take the derivative. F prime of x, negative 4x plus 8. Set that equal to 0 to find out where is the slope changing from positive to negative, hopefully. So we subtract 8, we get negative 4x equals negative 8, divided by negative 4, x equals 2. So that means we have our first derivative test, and we know 2 is our critical value, so we have to plug in something to the right and to the left into the derivative. And let's see. So let's plug into negative 4x plus 8. Let's plug in 0. 0 is to the left. So we get 0 plus 8. It's positive. Plug in 3. Negative 4 times 3 is negative 12 plus 8. Negative 4 is negative. So we have a max at 2. So it says find the x-coordinates of all relative extrema. 2. 2 is the x-coordinate of our relative extrema where there is a max. The x and y coordinates of the absolute max. So we know there's a max at 2. So we can go back and find f of 2 and see what happens. So we get negative 2 times 2 squared plus 8 times 2 minus 9, which is 2 squared is 4. 4 times negative 2 is negative 8 plus 16 minus 4, which is 4. So there's a max at 2, 4. Now, how do we know if that's the absolute max? Well, remember, when we have a closed interval from 0 to 4, we have to plug in the endpoints to see, is it higher? Now, you should be able to tell right here. Check it out. The function is going down to the left of 2. So it's only going to get smaller, and it's going down to the right of 2. So it's only going to get smaller. So, I mean, we could check because we should, but I'm sure it'll be less. So f of 0, plug in 0 to the original. Sorry, I don't know what's happening there to my pen. Oh, that's a 9. Damn. So that's negative 1. Okay, so you get, that's 0 plus 0 minus 9, so negative 9. So 0, negative 9 is a point. Okay, so that's too low. And then if you plug in 4, negative 2, 4 squared, plus 8 times 4 minus 9, that's 16. That's negative 32 plus 32 minus 9. So you get negative 9, so you get 4, negative 9. Some symmetry there. They're both going to be at negative 9, and this is in the middle. It's going to be a nice parabola. Concave down. We know that because it's a negative 2x squared. So the function is going to look something like this. Right? Where is this max? At 2. Determine the intervals where the function is increasing. Well, it's increasing from 0 up to 2. Parenthesis, and then where is it decreasing? So this is increasing, and then decreasing from 2 to 4. Okay, what does the first derivative tell us of the original function? right? It tells us there's a sorry, it tells us there's a max at x equals 2, right? Guess it also tells us that the slope is 0 at x equals 2. Okay? Good. Now, number 5 becomes a little more difficult because you have your derivative is going to have more critical values. So when you take the derivative of this, so f prime of x is going to be 4x cubed minus 4x, right? And you could set this equal to 0. So you get GCF 4x, x squared minus 1, which is 4x, and then some dots. Sorry, I don't know what's going on with my pen. X plus 1, x minus 1. So you get critical values at 0, -1, and 1. So now you're going to have to check a lot more regions, and especially since it's over -4 to 4, and all three of these are on that region. So mimic what we did up here. Remember, check in between each region and check the endpoints. That'll tell you what the absolute max is. And all the x-coordinates for the relative extremity we found. So now you just got to set your first derivative test, plug in, and go from there and mimic my problem at the top. Okay? So try that out, and then eventually this week we'll have a quiz on derivatives.